So let's get into it. You're the architect. You're the one calling the shots. And your job is to build the foundation for a mission-critical app on Azure Kubernetes service. But here's the thing. Just like a real building, if that foundation is shaky, everything you put on top of it is at risk. So today, we're going to draw up the definitive blueprint for an AKS network that's built to last. Okay, let's just get right to the core question. We all kind of know that an AKS cluster lives inside an Azure virtual network. But what does that actually mean? What are the real connections, the boundaries, the way traffic flows that makes it all tick? In this explainer, we're going to peel back all those layers and really answer this question from the ground up. All right, so let's start at the very beginning. This is the absolute first decision you have to make. Picking out and setting up the piece of digital real estate that's going to be home for your entire cluster. I want you to think of the Azure Virtual Network, or VNet, as your own private, totally isolated campus. Nothing gets in, nothing gets out without going through a gate that you, and only you, control. This is the fundamental security and networking boundary for everything else we're about to build. It's the cornerstone. Now, a campus isn't just one big open field, right? It has different districts for different things. And that is exactly what subnets are for. They are the logical fences inside our VNet that let us organize, isolate, and secure all the different parts of our cluster. And before we can organize our campus, we need to know what we're organizing. In AKS, the machines that do the actual work, the virtual machines running our applications, are grouped into what we call node pools. You can just think of them as specialized teams of servers, where every server on the team has the exact same job. And this right here illustrates a non-negotiable best practice. Seriously, your very first subnet should be dedicated to what's called the system node pool. This is where all the critical core Kubernetes services run. It's basically the cluster's brain and central nervous system. By putting it in its own isolated subnet, we protect it from our own apps, which means way more stability and a much stronger security posture. Okay, let's build on that. Our next subnet is for the user node pool. This is where your applications, your actual code, your containers are going to live and run. And separating them like this is such a powerful move. Why? Well, because it means you can have totally different scaling rules, unique security policies, even different VM sizes for your apps, and none of it will ever mess with the core system components. Okay, so our cluster has a home, and all its components are neatly organized into their own little neighborhoods. But how do we actually talk to the applications running inside those pods? And for that matter, how do they talk to each other? Well, that's the job of something called Kubernetes services. At a high level, the whole concept is actually pretty straightforward. You've got two main needs, talking inside the cluster and talking to the outside world. For that internal pod-to-pod traffic, you're going to use a service type called cluster IP. It's the default, and it keeps all that chatter safely inside the cluster's private network. Now, to show your app to the rest of the world, you're almost always going to use the load balancer service type. Now, here's the really cool part. It's how these abstract Kubernetes ideas you see in that first column translate directly into real concrete Azure resources. Just look at the load balancer type. When you create a service with this type in your Kubernetes config file, the AKS control plane literally goes out and automatically builds a real Azure standard load balancer for you. It's that seamless integration that makes this so powerful. Kubernetes says what it wants, and Azure just makes it happen. We've laid out all the components on our blueprint, so now let's actually bring it to life. We're going to follow a single user request all the way from the public internet through our Azure setup and land it right on a specific pod that's running our application code. So here's the journey. Step 1, a request from a user's browser hits your network edge. Maybe that's an app gateway or Azure front door. Step 2, that request gets forwarded to the public IP address of that Azure load balancer we just talked about. Step 3, the load balancer, which is always checking the health of your nodes, picks a healthy one in your user node pool and sends the traffic there. And finally, Step 4, on that node, a little Kubernetes agent called kubeproxy uses some smart internal routing to deliver that traffic to the exact right pod, from the internet to your code in 4 distinct hops. Look, understanding the flow is one thing, but as an architect, your job is to build a network that can handle the absolute chaos of a real production environment. So let's just boil everything we've talked about down to 3 golden rules for any production-grade AKS network design. Rule number 1, and if you don't remember anything else, please remember this. Plan your IP address space meticulously. This is the one thing you absolutely cannot afford to get wrong. You need to pick a VNet address range that is huge enough for any future growth, and this is critical, does not overlap with any of your on-prem networks or any other VNets you might connect to later. Trying to fix this after you've deployed is a complete nightmare. You have to get this right from day one. Next up, rule number 2. You've got to size your subnets for growth, not for what you need today. Don't just calculate the IPs you need right now. Think about your busiest day of the year. Think about cluster upgrades, when AKS actually needs extra IPs temporarily. A good rule of thumb? Just allocate at least double what you think you'll ever need. IP addresses are cheap. Redesigning your entire network is not. And our final golden rule: configure your network security groups and firewalls with precision. This is your defense. Your subnets need NSGs that enforce a least privilege policy, only allowing the traffic that is absolutely necessary between them. And all traffic leaving your cluster should be forced through an Azure firewall, so you can see, filter, and control exactly what your applications are talking to out on the internet. So the crucial takeaway is this: a well-architected network is the invisible foundation of a high-performing application. When you do it right, nobody ever even thinks about it. It just works. But when it's done wrong, it becomes the source of nearly every single performance and security problem you'll ever have to deal with. So you've followed the blueprint. You've laid that solid foundation. But, building for today is one thing. The real test of an architect is building for tomorrow. Your network is built. The question is it ready to scale?